Hello, today we're going to be going over CATIA Magic features overview with demos. So the goal here is to go over all of the unique features of this tool um, that help get you started developing a systems architecture using the tool. So we're going to be going over things like DataHub, which will connect you to other tools. We're going to be going over some advanced features, some demos just using basic features in order to build a systems architecture, and we're going to be going over some collaboration techniques using Teamwork Cloud. So for the first demo, we're going to talk about requirements. So our feature for this is DataHub. And this allows you to connect to IBM Doors, Excel, OSLC connectors, Innovia, and other versions of IBM Rational. In 24x refresh 1, we're currently at refresh 2, but in the previous version, we did add JAMA Connect. So I'm going to go ahead and give a little demo on how this will work in a model. But I do have a few resources here. There's an overview page with this PDF, and then there's also this video here that is displayed here on our documentation as well. But we're going to do a live sample here today. But before we get started on that, I want to give a brief overview of the model that we're going to be using for some of these examples. This model is called the generic patient-controlled analgesia pump model, and that's short for or long for GPCA, which we'll be calling it from here on out. So I just click this hyperlink on the top level model element, and it brings us to this index. And for the overview, I want to go to administrative. This is just something that I personally do in order to try to keep track of everything that's going on within a model when I'm working with other people. It's nothing that's required, but it is something that you can take advantage of. So the first thing I want to do is I want to go jump over to references, and I want to copy this link here. These are all of the different references that I used when I was building this model. Okay, so this particular idea actually came from the University of Minnesota. So this project was developed, I think, in 2013 and has had a few iterations with other universities as well. It's a pretty big initiative, and I took the outputs of all of this information and I created a systems architecture from it so that we could use this in the healthcare industry specifically in order to facilitate samples for that particular industry. So all of my samples and everything that I've developed here is a part of that. Okay, so now that we're past that, we're going to go ahead and we're going to demonstrate how we can use JAMA to connect with our requirements. So I'm going to go over to our stakeholder needs here, and we're just going to go ahead and go to Tools, Data Hub, and we're going to open up the Explorer. And once the Explorer is open, we can see I've already ahead of time connected to our JAMA client. And so now we're going to go ahead and connect to it. And that will ask us to log in. I'll put in my credentials and hit connect. Okay, it is loading. And now that we're logged in, we can expand this. And we can see that we have this automotive integrated system. We don't need this, so we're going to go ahead and we are going to add a new one. So we want to add a single JAMA project, and we want to select from this one here and connect. Expand this again, and we can see that we have access to this empty generic patient-controlled analgesia project. Okay, so now we want to come over here, and we're just going to drag these requirements over. Let's start at the package level. And it was just notifying us that there are certain HTML features that are not available for translating, which doesn't apply to us in this case. Okay, so now we have our mapping. So for diagrams, I'm going to go ahead and exclude these. I don't need these to come over. For packages, I want these to come over as just a generic requirement set. By default, it was automotive because I had done this separately before, but we just want it to come over as a requirement set. And then for the owning package, we will set this one as a requirement set as well. And then for requirement, this will be requirement. We are going to exclude this instance, and we're going to exclude the trace because I don't want it to come over in this particular demo. So now it is loading. It's giving us a percentage complete, and so we will just wait for this to be completed. Okay, now this is just a warning that certain elements could not be copied or have links created between them. This is okay, so we want to exclude all of those in the future. Okay, and now we're complete, and we can see our synced requirements here, and we can view certain properties from this window, and we can even jump over to JAMA, and we can see that these references are here, and we can see the text came over, the name comes over, everything looks like it has mapped properly. There's a lot more that you can do with this. You can go both ways, but that's outside of the scope of this particular demo. This was just showcasing one feature within DataHub and connecting requirements in and out of CATIA Magic. So with that, we will move on to the next demo, which will be requirements, traceability, and diagrams. So there's two different types. There's structural and then there's functional. Structural would be showing elements that are blocks, part properties, ports, value properties. And then functional would be like state machines, actions, activities, and sequences. There are a couple different ways to display this information. We have maps, and I'll go through each one of these in the model in a little bit more detail. We have metrics. We have matrices that connect different elements to requirements, and you can show the arrow connectivity between them. You have tables where you can create your own custom columns. And let's go ahead and jump to the model and see some examples of these. Okay, so let's go back here. And I'm going to try to go through using the index so that we can kind of get the context of where these would be used. So we're going to go down to the solution domain for those of you who are less familiar with Magic Grid, which is the methodology that we're using here. Solution domain is your logical architecture. This is your system solution that you are developing. It's not the conceptual view, which is done up here in the problem domain. It's the actual logical view. Okay, so different types. So let's start with a block definition diagram of our particular system. So a BDD, most people know what this is. This is just a breakdown, a decomposition of your system. So you can see our top level system block, and you can see its subsystems here. You can show ports, you can show constraints like we have here, value properties, or any other information that you see fit. Similarly, we can go inside of it, and we can see and you can see how these different parts interconnect. And you can see what actually flows between them. Now this view may be a little bit more confusing. I wasn't planning to bring up this feature, but since it's here, other people are editing this model as we speak. It's kept up to date for different demos and different things that we want to show, so things change. But I had marked this as complete, which is an option within our tool. And whenever you do that, it will actually show blue markers, as you can see here, for things that have changed. So this is an indication that someone has changed certain properties of this, and so we need to investigate what those mean, what have changed, if they are good or bad changes, or if we should go back. And we may talk about that a little bit more when we get to working within Teamwork Cloud, which is where this model exists. Okay, so the next type of diagram that I want to show you, we're going to jump over to requirements, and we're going to look at this derived traceability matrix. So what this is showing is that our system requirements here are each derived from the stakeholder needs. Because these are our system requirements, we want to ensure that they are coming from the stakeholder needs, and so this is a pretty powerful view in order to show that, because sometimes things are missed. We may think that we understand and can show everything about the system, but oftentimes we at least make a mistake here or there, and this is a good way to check ourselves and make sure that each requirement is traced back. Similarly, you can change that dependency criteria here to refine in this case, because now we're going from requirement and we're actually going from the system requirement back up to the white box. So these are different levels of abstraction. So these requirements are actually refining this conceptual domain here, because these are adding more detail to our conceptual system. So we use refine in this case. But we can change this dependency criteria. We can create implied relationships. These are very important so that you don't have to click, 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 as an old colleague of mine once said. And you can use this to save a little bit of time because there are implied relationships. You can create your own types of implied relationships. We have videos on that available as well. You can change the row scope, column scope, and the types of requirements that flow through here in order to customize this in just about any way you like. The next thing up that I'd like to show is our metric capability. So as you can see here, we have requirements, and we showed previously that all of our requirements in the system level were derived from stakeholder needs. Well, now we can actually see the numbers to that. There were 36 requirements and 36 of them are derived from another requirement. So then we can get a percentage here of 100%, 36 divided by 36. So this is another really good feature that allows you to kind of cut through the more dense diagrams where you may have hundreds or even thousands of requirements, and you can just get numbers here and really simplify things and show that you have a complete model. Okay, so we've gone over BDDs, we've gone over dependency matrices, and we've gone over metrics. Now I want to go over tables, specifically generic tables, and maps. So I said generic tables. We'll go ahead and we'll do the requirements tables just to stick with the topic. What you see here is a decomposed hierarchy here. So you can see that these requirements, even within this table, can show their composition. So this is nested within this requirement, which is nested within this requirement, which is a really neat feature to have. Then you can show properties like the text or where it's derived from, and then you can actually create custom columns using, you can use simple navigation, which would find just a particular property one-to-one, or you can use meta chains, which allow you to go deep into the hierarchy of the particular element's properties. And you can make these pretty complicated and parse pretty much anything you want in the model. You can even use find, and then we have a built-in feature for implied relationships like I spoke about earlier. So you can do some pretty nifty things with that as well. We also have operations that are built into the model for everyone to use, like different filters, equals, exclude, empty, and match, things like that are pretty useful. And then you can do property tests and other types of tests and filters. So you can get as complicated as you like. You can even do scripts, and you can use languages of your choice. We prefer Groovy. It's the fastest for here for this particular application, as it is Java based. And these are the others that you can use. And again, this is, I don't think I mentioned it before, but we're using 24x refresh 2 here. So these may vary if you're using an older version. Okay, so that's the custom column feature. You're able to pretty much generate any type of column that you want related to the properties of this requirement. Really powerful tool. And lastly, we'll go over our maps. So let's see. I don't remember where we put our maps, so we have another very interesting feature where we can go to Windows and we can show diagrams. And then we can just look and see where our requirements maps are. We have activity decomposition maps, and then we have requirement derivation maps. That's the one that I actually want to show. So let's go here. And this is the example that we showed earlier. So this map, again, these relationships can be changed to any other types of relationships. And this basically shows that we started off with a stakeholder need of safety limits. And then that was decomposed into system level requirements, 3 to be exact. And then this particular requirement, retrieve values from hospital database, was then broken out into 1, 2, 3, 4, 5, 6, 7, 8, 9 other requirements. And so you can see this can get kind of hairy, but it's a very powerful view for stakeholders. And I think that leads us to our first actual demo where we're going to actually be going and we're going to build a systems architecture, a really basic one. There's not going to be anything fancy in this, but it's just going to show you some of the really cool features in our tool to get started very quickly when modeling a systems architecture. Okay, so next up is, I'm just going to go through this real quick. So some of the MBSE enablers, just to preface the systems architecture. So we have the three pillars of MBSE: language, method, and tool. So the language is SysML, and our method is based off of the NCOSE Systems Engineering Handbook. And then the tool that we're going to use today is CATIA Magic. So there's a bunch of different methodologies available. NCOSE actually maintains the USM method, Object-Oriented Systems Engineering Method. There's methods by IBM. There's the SysML Cookbook. There's FAST by Tim Wilkins. And then we also offer Magic Grid version 2. And without trying to sell anyone too much on this, I will talk about why I personally use it and used it before I came here to Dassault Systems, and why I think it's a good method to start with. So Magic Grid is a framework. It comes with a methodology, a set of tools within CATIA Magic, and it comes with a book. And this book describes step by step the entire framework and all of the steps required to build out a basic systems architecture. Everything is right there step by step. Now, some of the other methodologies offer these things, but none of the, not to the same degree of getting started quickly that Magic Grid has within CATIA Magic. So this is a sample of the index here. You already saw that if you were here at the beginning of the video for the GPCA. I used the same index. Okay. So now we're going to go through and we're going to kind of see, we're going to build a model using Magic Grid, just so that you can see the built-in customizations. So we're going to create a blank model. We're going to use what's called the package structure creation tool. And then we're going to create a set of requirements. I'm going to actually import these, and then I'm going to show off the automatic numbering feature. We'll build a simple block definition diagram, probably based off of the GPCA, just because it's fresh in our memory. And then I'll show how easy it is to quickly create a BDD using the smart manipulator. And then we're going to use the quick diagram layout to make it all nice and neat so that we don't have to spend time actually moving blocks around and making it pretty, as many of us modelers like to do. It can be, sometimes it's necessary, but sometimes it can just be kind of a waste of time. If we're doing something that's quick and dirty for a demo or something like that, it's really unnecessary to lay things out in a specific manner when we can use this quick diagram layout much quicker. Then we're going to use, we're going to import some interfaces, some signals, and then we're actually going to show what it looks like to extend that to a separate project so that it would be a project usage. So that you can kind of see what it would be like to have a library. And you start with it in one particular model, and then you may say, okay, well, this doesn't belong here. This needs to go somewhere else, so we can export that. And then we're going to talk about Blackbox and Whitebox ICD tables and how they can be quickly generated using our tool. And then we'll go over some of the different report generation tools. We have a report wizard, and then we also have Collaborator. So without further ado, let's get started. Okay, so let's create a basic model. We're going to go to File, New Project, and we are going to do a blank Magic Grid v2, and we are going to call this Feature Overview Demo Model. And the first question that it asks us is, it's associated with Magic Grid. Do you want to change to the Magic Grid perspective? Well, what is a perspective? A perspective is a series of different views within the model, kind of these toolbars and everything, certain associations, like when you right click on an element, you might get a specific drop down based off of your perspective. It's all to kind of limit the view so that everybody doesn't see everything, because that could be overwhelming for new people, or maybe experts are, they only want to see a very specific subset and they don't care about anything else. So setting up your own perspective is a really neat thing to do, and Magic Grid comes out of the box with its own. So let's go ahead and switch to that now. Okay, and we're just getting this loading screen. It's building out the model, and we can see it's done here. I'm just going to hide this auxiliary resources. We don't need to see what's in the background. I'm going to close those, and we can see that this is the Magic Grid index. It's already built for us. It's got a little welcome here where you can start building your model, and on each screen it kind of describes, basically what this view is about and how to complete it. And we can delete that and then add our own system of interest up here. I'm not going to do that for the scope of this, but we'll do it in the future. So the first thing I'm going to do is I'm going to go ahead and get rid of all of this. And then I'm going to just show how you would create your, how would you use the structure creation feature. So you right click and you go to Tools, and you create package structure. And with Magic Grid, you have two that are out of the box. So let's do package for subsystem, hit OK, and you can see it automatically generates the structure for us, and we can update this structure how we see fit. And I believe if we want to see it, let's see, subsystem, we should be able to find it down here and manipulate it. Packages for subsystem. We go to specification and edit the values here. So we can come in here and we can actually manipulate this and add a hierarchy here to change this information. So it's a pretty neat feature if you want to be able to quickly display elements or package structures. But we're not going to be doing that for this particular situation, so I'm going to go ahead and remove these. Just wanted to kind of show that. Okay, so the first thing we're going to do is go into the problem domain Blackbox, and we're going to create a requirements table. And from this table, we're going to import from a file. And we're going to import stakeholder needs. And we're going to select OK. Oh, I did miss one step here. And that is there was an additional option that I wanted to hit. So before we do this, let's go open this file here. So we want the stakeholder needs, just so that we can kind of show everyone what we're actually pulling in. So when you're importing requirements, we have a mapping that you can do, but I always find it to be most beneficial to go ahead and create a table that matches what you're going to have in the Excel spreadsheet and then map it. It's just going to speed things up and cause less potential issues that we have to troubleshoot, okay? So we have ID, name, and text, just like in the Excel spreadsheet. And we're going to go back to it, and we're going to go back to the select, And then we're going to go to details. We're going to hit refresh here, and we're going to do this mapping right here. Now, it would have mapped it correctly automatically, but we want to make sure that it is mapping correctly ourselves. Okay, so let's do that. And the second time it doesn't pop up to let you know, but you can always go down here and go ahead and hit read file and then select requirement. And we can see that these have been imported in. However, they don't have the hierarchy that we like. They're kind of flat. So let's go ahead and just quickly move them. Okay. And you can see already that we have some automatic renumbering that's initiated here. This is another feature. And in this case, it's something that we don't want to happen. So we're going to hit back on this twice, and then we're just going to right click and we're going to go to element numbering. And in this case, we're going to go to details and we are going to lock element auto numbering.
Now we're going to go ahead and repeat the steps that we were doing before with our nesting. So we're going to take these, we're going to move them in here, and now we can see they have not changed their numbers because we have prevented that from happening, but we do get this hierarchy in the table, which is what we wanted. Okay, and with that, we're going to go ahead and move on to a system context. We're going to create BDD very quickly. Okay, so we can show a couple of different features here. First, we can drag and drop items. So let's call this our GPCA. We're not doing anything official here. I'm just, in terms of methodology, all we're showing is how to quickly decompose a system using some of the features within the tool. So this isn't going to follow any particular methodology. So we can use this. This is called a smart manipulator, and we can use a direct decomposition to decompose our system into subsystems. So HMI, power, system controller, and let's also throw in a deliveries mechanism. Okay, and then we can see this is kind of jumbled up, so we can use our quick start to get us, or quick layout to get everything looking pretty nice. And we can see we have a nice diagram here. So that's how it's pretty easy um, to quickly start modeling. And then let's just add a few ports here. We're not going to define anything just yet. This is so that I can show something later on in the demo. Again, we can relay out things here. Okay, so let's go ahead and import some signals. So I'm just going to do a generic table, add signals as what I want to the element type to be. And similarly, we're going to import this from an Excel file. All right. Um, Before we go, let's do some name and documentation. And I made the same mistake as last time, but this time we're not going to map. We're just going to read it, and we see that it figured it out by itself. So sometimes you need it, sometimes you don't. It just depends on whether these columns match. For instance, if I would have had documentation and name, it would have mapped those backwards. So if you know your mapping and you can create your table ahead of time, that saves some heartache. That's why I did it this way. Otherwise, you'll need to set up the mapping through the wizard like we did in the first exercise. Okay, so now that we've done that, let's go ahead and show that we can create a project usage based off of this. So we're going to export this to a new project, select OK, so that it can be reused. This is just saying, do we want to show the used projects that are hidden? No, we don't. Do we want to check for dependencies? You always want to check for dependencies because as these models get larger and larger, If you're exporting, it does allow to have some relationships in there that could cause circular references. So that's why we have this pop-up to prevent any types of cyclical dependencies ahead of time, since we allow you to do that. So let's go ahead and select yes. We're going to check for dependencies, so we don't want any errors in the future. And I'm just going to write over the one we already have there. Okay, and I'm just going to use selected. And here we are. Okay, so the next step is to do the black box and the white box. Since we don't have a fully fleshed out system, ours is going to look a bit empty if we try to generate it off of this. So we're going to jump back to the GPCA model, and we can take a look at some of the models that are already here. Um, and Well, this one is one that I needed to delete. This one was just showing that you need to know the context of the black box and the white box ICD tables, because depending on them, the ones you try to do, they will be blank. The reason why this one is blank, let's go Alt B, right click Alt B on the table, is because this is a black box of this system context. And as we see, there's no interfaces here. There's no ports. They're not typed. They have just these associations, and so there's nothing to be caught in this diagram. So that's why it shows as blank, even though we do have something for the system. So it doesn't work well. It won't work on that because there's no ports. But if we go down to if we were to go down to the solution domain, let's pick on the HMI, and we go into structure, we could build out a black box ICD here. We see um, it quickly generates this, so we don't have to do anything. And then you can manipulate it further if you need to fit your purposes. And then it wouldn't show much for the white box because we don't really have any internals defined. So that's, again, you need to know the context. So the white box is the inside of it. So let's go ahead and delete this one. If we want to see a decent white box, we can go up to the solution domain and we can make one here. And we can see that it is pretty well filled out. There's a lot of information here, and so now we're good to go. And you can see that it took very little effort to get all of this in return, just by using a simple template that we already have in here for Blackbox and Whitebox ICD. And now these can be changed, and you can create your own custom diagrams and such. That's kind of outside of scope of this particular um, demonstration. Okay, now let's jump over to the report wizard to kind of show the different types of reports that we can create and how to manipulate those and customize them for our purposes. So we're just going to generate requirements because that's all um, and we're going to use the GPCA model. Um, but each one of these, let's take a look at this one. If we open it, it will show the code behind it. And this language is called Velocity Templating Language, or VTL. It's a templating language that's used in a lot of database projects and things like that. And it's fairly quick and easy to learn, but it's not the most descriptive language, so it can be a little bit challenging to do some of the things that you can do with the more advanced programming languages. But you can still generally get most things that you want accomplished. So you can see that we can set up the introduction and all of these things. Here we have a SysML report helper, so it's setting the level of indents for everything depending on um, its level. We have a bookmark creator, so that we can bookmark each reference, and then it goes through and it does some manipulations with each of the requirements and things like that. Won't go into too much detail on that, but we do have trainings and things associated with this to help you get up to speed. Also, we have a bunch of training available under tutorial. So each one of these kind of breaks down a portion or a concept that you need to know in order to create your own template here. So these are really, really powerful to use. And you can do most anything that you need to do and generate from the model. In my previous life, I've generated different C drills, um, contractual documents, and review documents, and even for school, I generated final reports and things like that to PDF. So it's you can generate pretty much anything that you need to. So let's just see what we'll get from the built-in report. And we're just going to do the black box because we have quite a few different requirements here, and we want to kind of keep this limited in the size of the report because as your model expands, these reports can get really, really huge. As we can see here, this is just a small section of our model just dealing with the requirements, and it shows all the refined by, the traced, all the different types of relationships for each requirement. It shows what they are traced to. So this is a really simple diagram or a report that you can use to generate to get some quick information. Okay, and then the second way is we can actually use Collaborator. So in order to use Collaborator, we need to actually publish this model. And to publish the model, we can go to Tools, Cameo Collaborator, and we can hit Publish. And we select a scope. We'll go ahead and do just the problem domain again. You could do the entire model, and you can also edit um, these templates that are being used. Right now, we have SysML, so all of the SysML elements are going to get printed. We could do the whole model. We can create our own documents out of this. See how this is a requirements document? Let's see what this generates. Um, we can do quite a few different things with this tool. So now that the report is published, we can select Open Document down here. And if you miss that notification, you can just click down at the bottom here. It's hidden now that I have this open, but when I close it, you're able to see it there if there's any notifications. In this case, there aren't. So because I already reviewed the notification, so if we want to open that window back up, we can go to Window Notification Window and then select that. Okay, and so this is the document that has been generated. You can see each requirement kind of gets its own section here. So in this case, uh, this might not really fit the bill of a requirements document. You might need a little bit more from this. Um, there's, no introduction and things like that. But it does have an appendix, it looks like. Um, but what you can do is edit these reports and make them a little bit more sophisticated for your own purposes. And you can do everything that you did with Velocity and the other template and having the introductions and things and printing an actual document. And then this is web-based, but you can also then further come here and you can export the document to PDF. So that's all of the demo for the systems architecture and just quickly building up a few things. We didn't do any intense modeling or anything like that. Uh, the main goal was to just show off a few of the features to get you started. Um, and I call this quality of life capabilities and resources because a lot of the things I showed I think are quality of life. They improve your modeling experience. And so I provided links where I could find them for each one of those, like the element numbering, the report generation using Report Wizard and Collaborator, the quick diagram layout, and smart manipulators, automatic package creation, and the Blackbox and Whitebox ICD. So I will provide this to you, or you can type that in on the post that I make following this tutorial. Okay, the next section is Magic Collaboration Studio project usages.
Okay, so for this demo, we're going to go over collaborative modeling, access controls, version controls, branching, merging, and rollbacks. So Teamwork Cloud is a collaborative modeling environment which allows users to work in the same project at the same time. Here we see that we have a user, C. Klotz. He has these model elements locked, but up here we don't have anything locked. So nobody except for C. Klotz can go in and edit these files. Whereas this first package, anybody can modify it who has write access. Um, so you can lock elements individually or recursively. Um, we do have a slew of different access controls. You can read these here. Um, the main ones are going to be the resource creator, resource contributor, resource manager, and reviewer. These are going to be the ones that are going to be typically used the most. The other ones are more administrative purposes, and these can be read about on our documentation and our website. So we do have version controls. Every time we make a commit, it is its own commit and it iterates the number. And we have the ability to tag those as we can see here, we have a major for a PDR, just as an example. And this allows you to go and compare differences, changes, and revert back. Also have the ability to generate branches. So if you need to work on things in parallel, test new features, things like that. We also have another training that goes over some different rules and such related to that, so that users know when how how our tool was designed and what to expect and how to use it and efficiently without with the least amount of heartache. So we have a set of rules that we present in a separate presentation. So if you're at MCSS, that's available. We also have a white paper coming out on it as well. So look for that in the future. Um, in line with branching is the ability to merge. So once you make a branch, you don't want that just hanging out there. You want to be able to merge it back to the main trunk, perhaps. And so we do have that capability, and also the capability to then um, compare those differences and select and deselect changes from a particular branch. So you basically what you bring over to the trunk is going to be the best of both worlds, and can be customized as such. Also, a lot of customers and even internal customers back in my previous life um, were confused about the how difficult it is to roll things back. So Everyone's very scared that they make a change in a model and it breaks everything. Well, luckily, we have a rollback feature, so all you have to do is go to the project history and you can set the previous version as the latest. So if you did perhaps mess something up and you committed it, you can revert that very easily um, within a minute or two. So no big deal there. We also have a resource usage map. So as our project usages get a little bit hairy, it's valuable to be able to see what projects are using what other projects. It's also helpful because we have a feature that will show you if there's any cyclical usages, and these are bad for many reasons. One of which essentially it makes any errors in the model much more difficult to deal with because you fix it here and then you have to fix it here and then there's remnants of it here and then you go back and forth playing whack-a-mole, and also it can create some other complications as well. Okay, so now we're going to do a little demo. I'm going to open up one of our projects, show that usage map, lock the model. We will create some diagrams and drag and drop some things on there. And then we're going to do a commit. And then we're going to roll back those changes. Okay, so let's go ahead and start. Okay, so we have the vehicle climate control system. This model comes in every version of Cameo, so you can check it out in the samples. This version has been uploaded to our Teamwork Cloud. And the first thing that I'd like to do is I'm going to go ahead and I'm just going to commit to a new branch. I'm going to create another demo branch, and as you can see, that's a popular thing. Normally, we wouldn't have in a production environment such as yours. We're not going to have all of these demo branches, but because um, we continuously do demos and things like that, we kind of have those hanging out. But in a production environment, you're going to want to have some rules on how long those stay there and clean things up periodically. Okay, so let's call this feature demo, feature overview, demo. Okay, and I'm not going to branch any used projects because I don't want to change any of them. We're going to use the trunk on all of them. The only one we're going to change is this VCCS. Okay, and as we can see, we now have a new branch. So let's go ahead and select OK and select OK. And then we will commit this, created new branch. Again, it's better to also leave some more detailed comments because as you're working with a group of other individuals, they're going to need to know a little bit more information than what I specified below. So try to give as much detailed information as you can when you're collaborating with others. It will save you a lot of time in the future when you have to go back or there's a new person that needs to get up to speed and the person who's been working on the model has left and they didn't leave any comments. It's going to be much harder for people to get up to speed. Okay, so now that we've created our own branch, um, what I'm going to do is I want to be able to show the merge feature. So I'm going to create another new branch real quick, and I'll probably, um, so instead of merging back to a trunk, I'll merge back to another demo branch. So the next thing we need to do is we need to switch over to our feature demo branch, and we actually have that open here. So what we're going to do now is we are going to just, let's create a BDD. And I want to just basically show that we can reuse model elements from, I guess that's a bad example because this is a grouped requirement. So we'll just show a little hierarchy here. There we go. And let's select all, display, all paths, clean this up a bit. Okay. But anyways, we can see that this is all being used from the problem domain model. Might not mean much to you yet because we haven't looked at the hierarchy. So let's go ahead and open that up. So if we go to Collaborate, Open, and Resource Usage Map, then we can see this. And it looks a little bit jumbled right now, but we can clean this up by moving some things around. And also by understanding the hierarchy makes it a little bit easier as well. Not that that is a requirement because we're going to use this to better understand the hierarchy. But it certainly helps when you already understand it. Okay. So now it's a little bit more clear. So the way that a magic grid model starts is with a problem domain. So we take the entire vehicle and we create a problem domain from it so that we know what the stakeholders want and we can conceptualize our system. Once we've done that, we generate multiple one-to-many solutions um, for that problem, and then we down select the best solution. Once we have selected the best solution, then we create subsystem models for that solution. And those models then use the solution as a foundation for building out their solution so that we can reuse model elements. So this is from here down, this is called a bottoms up approach. Because we're going down in the level of abstraction, but we're looking down and we're seeing the higher level of abstraction with the problem domain. So bottoms up, and then we switch that to the configurate. Once we get to a configuration, we select the solution domains, and again there can be multiple here. And this is just one methodology. But it helps to explain why this hierarchy is the way it is, and it'll give some context to when we are merging things back together. So once you have this vehicle configuration, now we're switching to a top-down approach. So we have the configuration domain, which is the entire system, and it's built up of these building blocks, the subsystems. So that's back to a top-down approach, and then we have the final system, the vehicle control system, which it sees everything, and is similar to the vehicle configuration, but it has a little bit more detail and is built out to the physical domain with the implementation thrown on top of it. Okay, so now let's head back to the model. And we've made this BDD, and we're going to go ahead and we're going to commit these changes. And I'm going to break a rule. I'm not going to add a comment for the sake of the demo. So bad on me, but you should definitely do that. Okay, and now I am going to have a review, and in the review we find that, well, we really didn't need this BDD. So let's go through the history here, and we can see, and we can compare, and we can find out what elements changed here. And we'll see that a BDD was added, and then we can revert that change. This isn't the only way to do a comparison. You could publish the model, but we didn't do that here using Collaborator, and review it there and have comments. We're not showing that here, but it is another way to do it. Okay, so we can see that in the base model 25, version 25, we have the index, and now the model, the top level model element, owns another diagram called model. Okay, so we can see that that diagram was added. Now let's look at it and we can see, okay, so this was added and it doesn't really look like there's any other features. We could generate a full report or diagrams report, etc. But I think we're pretty clear on this, so we're going to go ahead and close that. And since that's the only change and we don't want that change, we're just going to go ahead and select 25 and say, 27, and none of that needs to happen. So we're going to set 25 as latest, and we're going to go from there. Okay, and now we need to open that branch or open that version. We could have also just stayed in the version that we're in and updated. Doesn't matter which way you prefer to do it. Okay, so now we can see that that BDD no longer exists. So now let's make some additional changes. Okay, so we are going to modify some requirements from the implementation domain. These are some that was added in a previous demo. And so we're just going to come here and I'm going to change this to 20 millimeters. And I'm going to add an additional requirement here that we're going to call remote start. So let's just say remote start, and we want to be able to start the vehicle from our iPhone or Android device. The user shall be able to start the vehicle from their iOS or Android device. Now, these requirements don't necessarily make sense for a implementation domain because we're actually getting physical. But this is more to show the ability to merge requirements than it is for a realistic um, realistic demo. And unfortunately, I'm not as creative as some of my colleagues are, so you'll just have to bear with me on that. Okay, so let's go ahead and commit these changes to server, create a new requirement, an implementation domain called remote start. Okay, so now that we've done this, we have enough to then go merge and decide what we want to keep. So let's open up the trunk demo. So we will select the branch from here. So we're going to go to the demo trunk. And we are going to open that model now. And then we are going to merge from this model. Okay, here we are. So now we'll go to Collaborate, Merge From, and we will select that previous branch. And we do want to merge with locks. You can merge without locks, but it's best to, whenever we are performing a merge, we want to make sure that it's isolated. Nobody has it locked. Everyone is out of these models because, or at least out of these branches, um, because we don't want to run into any issues. So let's merge with lock. Okay, so now we have our merge result. We can see that 3 things were added and 3 things were modified, and we have a little legend down here. So we see that the implementation requirements were changed. We can see that pipe diameter was changed from 19.5 millimeters to 20 millimeters, and we're going to accept that. And then we're going to take a look at this remote start. Okay, the user may be able to remote start. That doesn't really look like an implementation. That's not a physical requirement. Um, it's not really the level of detail that um, we would require at this level. So I'm going to go ahead and not approve that, and we're going to have to go back to the drawing board. The person who created this is going to need to be need to come up with something different because this is just inconsistent with this particular domain. So let's go ahead and we will reject this. And then let's go ahead. I think that's everything. So we'll go ahead and we can okay, that's everything. And now we can finish merging and we'll get our result. Okay, so we see our model here. Let's go down to the implementation domain and we can see that this change did come through, but our additional requirement that we created did not. So we're going to go ahead and we will commit those changes. And that is the merge feature. And finally, we have some advanced features that we're going to go through. So the first one is the DSL example, so that users have the information to customize the model in their own way and start the process of knowing where to go for the custom profiles. We're not nearly going to cover everything that you need to know, but we're basically just going to go over, show the examples of what are there, and so that you're aware of them and can find the information that you need. So here we are. I've modified this a little bit, so yours will look slightly different, but there is an online demo available here that talks all about this. But essentially, what this is a custom made org chart. Right here, I have a table that basically shows the information here, the applied stereotype. So No Magic Inc. is a company type. Then we have a System Analyst 1, which is a project member, and then these updated DSL samples, these are a task. So these are custom stereotypes that were created that have even more customizations behind them. So a company, you can talk about what types of diagrams can own it, what types of elements can own it. You can give other properties like multi-line text and much, much more. Again, I'm not going to go into too much detail here. This is more of an overview of where everything is and how you can find out more information and study this. We have much more in detail um, presentations and demos that we do, and so look for those at MCSS, and also you can always reach out to us for training as well. Okay, so the next one is definitely my favorite. It is the case studies for querying the model. This page was created by Osvaldas Jankauskis out of Lithuania. He's one of our R&D developers and just an amazing individual. And he did some really great work here. Basically, over the last 10 years, he's been taking customer information and anything that's common that a lot of customers have needed to do that have to do with like queries and things, customizations like that. He's been documenting these simple problems and he's created a case study model for it, which we can actually open. But all of these are documented in pretty good detail here, and each page shows the case studies. So let's jump over to the model and take a look-see. Okay, so here we are. This is case studies for querying the model. Um, and you can look through it in a couple different ways. When you open it, they're all open across the top in different content diagrams. You can use the containment window. Let's hide these auxiliary resources. And it's essentially the vehicle model that comes with the samples. And he created these 16 case studies that basically help parsing the model. And then you also have a little custom view here that just has this filtered out. So these are really, really, really good because they basically teach you how to use the advanced features in the model, like custom columns in this case, or not in this case, but customizations, meta chain navigation, using some of the more or the less known features and logic behind it. So if we go to the vehicle conceptual subsystem, IBD, you can see this. Now we have this kind of out of the box now. You can actually create this automatically using the legend. You can extract legends and it'll create all this. But we didn't always have that. And so it's still a powerful exercise to go through and see how you would manually do this. And the logic's changed a little bit as well. We have some videos on this on the MBSE the CATIA Magic page. So if we go to the CATIA MBSE and we go to playlists and structured expression tutorial, we see that I've have these videos here that I went through. Basically going through in detail each one of those, and we've done the first 6 so far. We plan to finish it next year, but those are available to you as well. I always say if you have members that can go through and understand all 16 of these case studies, they can pretty much understand how to parse anything within the model, and I would consider them to be experts. And then finally, we have simulation. So anybody who's seen MBSE Execution YouTube channel, that's a great YouTube channel for MBSE and simulation. So if we go here, um, this is Saulius's page. He's got all kinds of information about simulation, and I'm going to showcase one of his trade studies here. So if you join the CATIA Magic group and you do a login, so he has this trade study hands-on tutorial for SysML where he's documented all of this information about it, giving you the sample projects and even a video and everything. This is a really powerful example. which we can take a look at here. Um, so this model is an excellent example of trade study analysis where Soleus has taken the satellite model and we are looking at different key points such as cost and mass requirements, and actually we are able to use types here. We're able to use Excel spreadsheets and instance tables. He shows all of these different ways that we can finish out this trades, that we can parse that information for trade studies. Additionally, I have another way to parse this through opaque behaviors as well and connect all of this information. So as these change, we don't have to do any post processing to find out where any of this information is. We can grab it automatically. Um, but this is a really good example because he has the trade study built in, and it shows and generates documentation. Just switch perspective here to system analyst because this toolbar wasn't showing. So we can actually use the simulation here, and we can see it starting, and we can see that that information gets logged in the result location. Um, Under results, and then we can look at the instance table and see all of this information and why a particular one won in this evaluation. So this is a really good example. We also have a ton of simulation samples. So if you want to see like user interfaces and some of the more complicated types of things, we can go under simulation. And the one that I really like to showcase is the coffee machine example, just because it has a pretty cool pretty unique user interface, in my opinion, and I like to see that one. So we can actually put in some money. Let's put in €2, and let's turn on the machine. And all of this is customizable. You can create this within the tool. You can add your own pictures. You'll see here you can flip through pictures. So once this is done heating, a coffee mug would appear, and even the liquid within the drink. It's called an image flipper or image switch, sorry, and you can see it going back. So let's hit cappuccino, and we see we have an empty cup, and now we have liquid in the cup, so it's switched to the image with the liquid. So, and then it shows that we added $2, we subtracted $2, so our change is 0. So this is a cool example that users can start with, that kind of showcases the simulation capabilities and user interfaces of our tool. So with that, the final thing that I will say is we have the community. Feel free to reach out, ask questions there. Soleus's post is there. I'm going to put this video there, and I'm going to create a post for this video as well. So you can again go to go.3ds.com/cybersystems and create yourself an account, and then you will have access to the CATIA MBSE Cyber Systems group. Look forward to interfacing with you there.